Good morning, week 9, Thursday, which means the audio service that we started on yesterday is more or less a thing. It reveals a pattern that I think is probably worth talking about. This is something that's come in handy throughout the project and has seen a success that means the modifiers in the game, the hats, the achievements, achievements, modifiers, hats, achievements, the sound now. These all work more or less using this one pattern of how to handle data when there is some core underlying asset and you want to attach some metadata to that asset in order to bring it into the project somewhere and place it in a scene. So a really good example of this is a audio clip. So we start with an audio clip, and let's say we've got a WAV file. So in order to actually play this in Unity, we need to attach to it metadata. We need to attach to it which mixer channel are we going through in Unity's mixer board? Which mixer channel are we going through? What volume should this be? What pitch should it be? All of the exposed variables essentially from the audio source. So above any clip is an audio source, and this is the Unity component. And then the audio source has on it an exposed, text in this guy, has an exposed audio resource. So the audio resource that the audio source uses is this audio clip file. So this is just a file of you making duck sounds or something. And then you attach to it a whole bunch of metadata that helps the audio source determine how it should play this underlying clip. So what has been handy is to take this and package this. So we can use a scriptable object to package this into a package. And let's say that this is, where's my camels? Man makes duck sounds. And maybe we have some ID for it. So this is now the man make duck sounds scriptable object, which is this audio clip packaged with a whole bunch of metadata. We don't package an audio source with it. There's other clever things going on there. We just package this audio clip and all of its relevant metadata. If we take a list of these then, so we've got man make duck sounds, we've got jump, we've got sing, and we have now a database of these scriptable objects. So now at the bottom level, we have a clip, and a clip goes into a, let's call it a clip data. So this scriptable object that we're constructing, we'll call that a clip data. And then this clip data could go into a clip database. And then our audio service, which was our original task here, our audio service can dip into that database to fetch clips. So it's a way of packaging our audio clips with the metadata that they require to actually play in the project. This is a pattern that I'm probably just gonna bollocks up on the whiteboard. If we come into Unity though, we can observe this in its home environment. So here are all of the things. So these are the clips. This is these scriptable objects, these clips, and here's how they've been packaged. So they have a clip name and an ID. If we put those two things together, it becomes the file name. This is so that we can run a correspondence with an external spreadsheet that might be tracking, you know, what one team member's done, what the other team member's done, what our planned clips are for those. It could be that the audio eng maybe comes along to the spreadsheet and goes, hey, I've got these 10 clips actually that are replacements for these, updates the spreadsheet, and then I could come in as the developer and go, okay, so rotate tetro is 10, go to the spreadsheet, look up 10 in the ID, and I'd know, oh yeah, this is the clip that the audio eng intends me to use. So all these little packages. So within a package is the clip itself, some default volume, a default pitch, whether it's meant to be a looping clip or not. Do we randomize the volume by some small amount? Do we randomize the pitch by some small amount? Obviously, if I clips that are going to be played in quick succession. And is it 3D or is it 2D? Does it have some volume drop off based on proximity to a point? And these, like, none of that should look too tremendously new, because if we go to one of these guys and we look at the audio source, it's essentially these parameters that we've packaged to be loaded into some audio source, which is the other piece of the puzzle. So this is an object. It is an audio source component with a transform, which obviously they all have to have, and this pooled audio source script that just means, I haven't even opened Rider today, coffee break. So there's an example usage here. So this, give me that one. This essentially subscribes to a pause and an unpause system for pausing scaled time, so that when we pause the game, any clip that's playing pauses. That's just the event that drives that. So that's proprietary to our project. All this does is exposes a play clip, loads in variables that are the metadata that was packaged with that original scriptable object, and then when you're done playing, return yourself to the object pool. So this isn't just a pooled audio source. The audio service, this big guy here, you can now hit from, let's say, block reg. We had an example here. So block reg now just goes to the audio service. Hey, play me a 3D sound effect. Play me the block destruction sound effect. And because it's 3D, we need a position. Play it at this position. And if we go to our data, we can see, oh, block destruction. That's the clip name, block destruction. So that's how we're retrieving it from the database. The service just goes, hey, I'll go see if the database has that name in it, and goes and grabs that name. Our database, we haven't actually looked at yet. This is our database. So these are all our clips in the database. Now, our database just keeps some dictionaries of clips with their names and clips with their IDs. So you can retrieve clips by ID or by name, and it will return you the clip. There's some like on-validate stuff here that's required, but there's even other ways to do that if you just wanted to build at runtime. A lot of this is just API that's exposed that I'm not using in case you wanted to be able to retrieve things. So it's just good database practice to expose some various capacities for users to interface with the database. Maybe the user doesn't know the name of the clip they want and they just want to get all the clips, or some such activity. So there's some, or maybe this is a good example. Maybe I know the audio clip I want, but I don't know its name or its ID. So I'll say you can work this database a handful of different ways, and this is exactly the same pattern then, like I was saying at the start, that we've used for the databasing of modifiers, hats, achievements, all that different stuff. So this was all pretty much just paint by numbers to get that in. the audio service does some other clever trickery. So I had to find a way to deal with instances of sounds. Obviously, if I play two sounds and they've got, you know, a wave like this and a wave like this, and I play these two sounds at exactly the same time, I end up with a taller peak here due to the additive nature of this wave theory. I end up with this tall peak, which is just really loud, and we don't want that. We want to be able to play multiple instances of the same sound at the same time without them getting too loud. So initially my system was that the audio service would just track instances, and it would say, hey, I've got 3 instances of that playing now at the same time. I'm not going to play a fourth. If you ask for a fourth, you don't need it. That sound's already playing. And that worked okay. It still means that you get a little volume peak where there's 3 playing at the same time, which wasn't ideal. And you do actually technically lose sounds because you're discarding instances of sounds. What we have now instead is, it will play the first one, it will detect, oh, you've asked for a second one, and then what we'll actually do is reduce the volume of this one so that the incoming instance is at a 1 volume and that this one sits in underneath it. And then as soon as we hit 3, what we're going to do is scale these in like a cascading manner. Scale these so that this guy is always going to be at like a like a 0.7, and then we distribute the remaining volume between the subsequent waves in a descending fashion, so that in total we come out with a volume of 1, but that happens distributed over these instances of the sound, so that as new sounds come in, if I add like another one now, that one becomes the highest priority sound, and you hear the start of the new clip really clearly, and the tail end of the remaining clips drops off. You can still hear them, they're still there, but they drop off quite rapidly, which this feels and sounds much better than this situation did. That's more or less the system, which is looking and feeling quite good. So today is just a case of actually going through this database and just updating all of the clips, because I'm still using most of the old sounds and a lot of these don't have a sound at all. So it's a case of going through and finding the sounds and seeing what we can do about making it a little nice.